Storm Prediction Center has issued a level 3 out of 5 enhanced risk for tomorrow. This will be June 18th on Wednesday. This will be mostly wind-driven enhanced risk here, but you can see we have a good amount of people under the gun for this. Indianapolis is in that region, southern Illinois, inching into Evansville here as well, all the way up into Michigan. So from Missouri to Michigan here, and this is mostly a wind risk. I wanted to talk about this because it's been a bit since we've seen some severe weather in the Midwest, from what I can understand, and this will be more it's more localized here. So this could be a interesting event as well as a large slight risk around that, including Chicago, the rest of Indiana, and just other portions of these states here. I also do want to mention, as of right now, we do have this moderate risk out for Oklahoma and Kansas. That's not going to be the focus of this video, but it is, if you're watching that in time, just do keep that in mind. You are under a 45% hatched wind risk day, significant hail being likely as well, and then tornado risk also being a factor. Here our day 2 outlook for focusing on this video. Again, wind is going to be our main threat. It's not something super significant. We do have this enhanced risk driven by wind. We don't have a hatched area anywhere. Looking at hail, same thing. We don't have a hatched hail risk. The tornado risk is higher for this. I wouldn't be surprised if we end up with a more organized setup, if we will see grade on the tornado threat. Obviously here, looking at the way this map is, main tornado threat's probably going to be somewhere in this vicinity here, western Indiana, and kind of this vicinity over here. I don't think we'll see an upgrade to 10%, but that's where it would be. That's where our main tornado risk will be, right here where storms can stay the most discreet. Let's look at the actual meteorology of this now. Here's our wrap run. I'm going to use the model forecast as usual. This starts with initialization, and these models tend to be pretty accurate only in the next few. This is our jet stream here. We can see the United States here. Here's the Gulf of Mexico, coast there, Texas into Pacific coast again. There's our country there. And we'll notice here a little bit of a troughing feature. This is going to be forming those storms today. You can see how this trough dips down into Kansas, helping with some divergence aloft. That'll help lead to some storm coverage. Watching this trough go into Wednesday, you'll see it starts to deepen pretty extensively. You get better jet stream ahead of it. You won't see that as much on the 250 millibar map, but you do get that trough. We moved down to 500 millibar. A little more drastic change here. And we have this same setup for down there, Kansas, Oklahoma. Notice just how you have a little bit of a ridging feature, increasing our jet strength here. Get this deepening of a trough kind of over Iowa. Notice some of these contours starting to inch more south with time. Notice we get a little bit of a 500 millibar jet streak out. That'll be a main forcing mechanism, especially. Temperature, we don't really have cold air going on. Maybe a little bit of cold air from behind, but for the most part, not a super intense trough, or not a super intense cold up or anything like that. 700 millibars, it's a very similar story. It's even stronger as you go further down. That jet streak very much apparent there. Maybe even a little bit of a negative shortwave ahead. That could also be a little bit of so get a close contour, so we get this deepening trough. Might be a little bit of a shortwave associated with this jet streak. So imagine we're drawing our jet quadrants here. Drawing our jet quadrant, and this is only at 5 or 700 millibars, so not the best to look at, but you'll get your best area for lifting two regions of the quadrants. So that's kind of where we're seeing it, right? We have this more tornado risk over here, Illinois, Indiana, and then we do have this long, elongated down here, kind of all the way down to Missouri, associated with the other exit or entrance region of that trough. 850 millibars, again, very similar story. A little bit of southerly winds, but not impressive. Usually when we have these setups, we want to see, well, for storms, they want 800 millibar winds southerly. We have some of that southerly extent, but for the most part, more southwesterly, and that's why we're more towards a wind setup. Notice how this does increase in intensity with time. This is 21Z, that's 4 p.m. Central Time. In the morning of at 7 a.m., I mean, you don't really have any jet strength for the most part, but you end up starting to get close to 50 knots there, or around the 40 knot range as time goes on here. At 4 p.m., you really start to see that increase in strength in the nighttime hours. Again, very typical with 850 millibar jet is the increase in strength throughout the day. Temperature, I'm looking for you see a little bit of 850 our cold air advection, that'll help strengthen this trough. Notice how you do have some of this cold air advection on the backside, and the closed low here is 1470 decameters. It decreases down to 1440. So generally, what I'm saying here is the trough is strengthening with time, and that's going to be a really important factor to this. Our moisture as well. We have plenty of moisture to work at the low. That will be a very good thing for these storms. And lastly, surface low, you'll see this increasing in strength with time here, going down all the way to 10:02 by the end of the day. Well, it's pretty late in the night at that point, but you do get this strengthening low with time. And moisture, again, very much in the picture here. Noticing kind of a stagnant cold front right here, but you do get a strengthening low kind of. So you kind of there's a little bit of an open warm sector kind of in this vicinity here, a little kind of stagnant warm front, stationary front set up there. Very slow moving cold front behind it, but a very broad open warm sector, a broad open warm sector, and it's very moist as well. That's what we'll be paying attention to there. Let's look at our instability. This is Cape. Jules this all the time in the channel. Surface-based Cape, we'll see how this is. Remember storm fuel here. For the most part, our winds are out of the south, pretty intense warm air advection here at the surface. We have our surface winds laid over this, again, 10-meter winds. This is surface winds. Lots of instability being infected very quickly, even unstable in the beginning of the day. Notice kind of where our open warm sector is here in Illinois, and a good amount of instability for the Midwest, upwards of 3,000 Cape. You'll get some good. Most unstable Cape, I don't see anything indicating like elevated convection anywhere. But again, instability is definitely at play. Theta E here, and very unstable air mass. Remember these more bright colors into the pink. Unstable air mass, potential temperature. Theta E is very unstable air mass. 3 Cape, one last thing I want to look at. 3 Cape, sort of lower level instability. That'll help more with your threats for tornadoes. So if you're able to stretch any low level vorticity vertically with 3 Cape, so that's 0 to 3 kilometers instability, lowest levels in the atmosphere, with the best higher 3 Cape, you can end up with better storms or tornadic storms from that. Notice how we do have a very broad area of instability here. The greens are above 100 joules per kilogram, which is typically adequate, and the fact that we have such an open area of this is going to help that threat significantly. Even here, upwards of 200 joules per kilogram, it's nothing to scoff at. Look at our HRRR run for this. Look at our simulated reflection. And here's our storms from today going on a line right there. This could help strengthen the surface low as well, because you often see sometimes with storms overnight, they'll form an what's called a mesoscale convective vortex that'll actually strengthen a surface low. Looking at the morning of, probably some showery activity ahead, just because off surface low like that. Very quickly here, you end up with storm development there. That's 16Z, very early on in the day, right? That'll be 11 p.m. You're nearing lunchtime here. Lunchtime storms. Definitely a kind of an early morning setup going. If these are able to consolidate correctly, they could get into this wind line. Possibly some little mini supercells ahead. Actually move back to a wrap model and get some sound out ahead of this. Sounding. Basically right ahead. We'll take one from like right here, because that's about where our storms were going. Actually, let's look at our updraft helicity swaths as well. See, our updraft helicity is how much rotation there is. Definitely seem to be more rotating, kind of here in this talked about, like Valparaiso, Indiana being around there, Gary, Kankakee, Illinois, upwards into Michigan maybe, or just Michigan over there somewhere. I'm not the best with my Michigan geography, but this general area is going to likely be our main area for any storms that are rotating. Sorry, didn't mean to show my calendar, but hey, yeah, this is kind of a bad contaminated sounding, but we do have a little bit of that curvature of the photograph. Basically, what you want to see. From Slinky also really shows that bean shape, kind of like curved little kidney bean. That's indicative of small, low-topped supercells for the most. Might be a float here. Let me try the floater. See if I can get a photograph map. Okay, so I can't get a photograph map, it looks like. able to get one of those. I guess not for this region this time around. Let me see if I can get a better sounding, just to outright wrap model. Go to the wrap model and get a. There it is, photograph. All right, that's what we wanted. Here's our surface-based cape underneath photographs. Before the time here, oh, this is NAM photograph map. Sometimes the websites get a little funky. That's okay. That's our photographs here in Illinois, and this is kind of the best sector I can give you. Early morning, we do have those little curved shapes. Instantly maximizes early 19Z, so it's kind of 2 p.m. after lunchtime, but you can see that curvature there. If those lines do form, pretty good for storms, especially if they're able to take in any of that surface vorticity. Actually, check that too. Lots of stuff going on here. 3 Cape is outlined by the contours, but notice the colors, reds. That'll be our surface vorticity. Not super intense ahead of the, but again, it just depends on the storms. This kind of a lower end enhanced risk, I would say. We do have that wind risk certainly. Okay. And looking at our cam here, I should look at the NAM nest as well. Here, HRRR, again, we had that line form pretty quickly. Main tornado threat will be up here in kind of northwest Indiana, southwest Michigan. You can see those storms do form very linearly onto the northeast pretty fast. NAM nest model, we'll see how this coverage goes. A second round afterwards as well. And you can see those storms forming very kind of more discrete than the NAM nest here for a little while there in northern Indiana. And then they consolidate into a more linear setup as time goes on there. So maybe even a few cells behind as well. That also could be 2 rounds of convection. That would be interesting to see. Big 2 soundings. This one is our, that one. Check this one. So we'll look at both of these and see how the NAM nest is nice to see. Again, just a reminder. Being the main risk, I'd say tornadoes being secondary. Yeah, so here is our sounding behind. And you see the dynamics aren't nearly as good. Thermodynamics aren't as impressive, but still very much a setup that could be favorable. Storm Slinky's not great here. Yeah, Storm Slinky's just not great. Neither is the photograph behind. This is ahead of the first wave of storms here. It's much more tornadic. Here with that curvature looking a lot better. Again, still low level curvature. These are probably going to be low top supercells if they are able to form. Our lower level instability is going to be our main, kind of the main helper to the severe threat. Lower level instability. I won't be able to chase or anything. I'm currently in Tampa, Florida, but is so I'll be keep watching on the Midwest. If there's any updates for this forecast, I'll let you know. But yeah, main gist. So just keep an eye out for winds if you're in that region. Again, I would still bank on the main. Kind of corridor right here is probably where I would place the main. Right, I wouldn't be surprised to see more of a risk extended kind of further east. That line is able to organize more. I'll keep tabs on that because it's very possible more models either inhibit it or say, yeah, this is going to happen. So more model consistency is always a good thing for you. So, but if this forecast again, this is for we do get a new convective very soon, which in the hour. So this is a different outlook. I make a post or something, but I don't anticipate a huge change. But yeah, so if you have any questions on this forecast, please let me know in the comments. If you've enjoyed this, yeah, that's it for this. Thank you all for